In this video, we'll be taking a look at Apache NiFi. Apache NiFi is an open source tool that enables you to manage flows of data between systems. And so whenever you are getting information from point A to B, there's multiple things that can go wrong. Networks can fail, software can crash, and sometimes the data coming in is too large or it's coming in too fast. And so NiFi will handle all of this stuff under the hood. And so some of the core features of NiFi are guaranteed delivery. So no matter what, even if the software crashes or whatever, when it comes back up, it will deliver this data. And you can imagine this being important for, let's say, bank transactions. It also has data buffering and pressure release. And so whenever a application that is consuming the data is being overwhelmed, well, NiFi can actually buffer this data and match the pace of the application. It also has the ability to delete data after a certain amount of time has elapsed. It has prioritized queuing, and so sometimes, depending on the application, you're going to want the newest first or the largest first or whatever, and so NiFi allows you to configure that. And then we have quality of service, which essentially means that NiFi, again, you can configure it to prioritize latency over throughput or loss tolerance. And so before we continue, it's important to clarify a bit of the terminology around NiFi. At the core is the idea of processors, and processors are the things that actually do work in NiFi. And by work, I mean performing operations on the data, so actually transforming it, or even loading it from one source and sending it to another. Some examples of processors are get file, so this will actually load data into NiFi from a file, let's say a CSV file. We have update attribute, so we'll get into flow files in a bit, but essentially update attribute will add a attribute or make a change to an attribute on the flow file, which is essentially just metadata. We have publish Kafka, so you'll tend to see NiFi used in conjunction with Kafka, and the publish Kafka processor will actually send messages to the bus. Another term is a process group, and that's simply a collection of processors and their connections. So it's just helpful to organize your graphs, I guess. And then we have controller services. So controller services will be made available to all the processors in the process group. And some examples of controller services are the Avro schema. And so this will essentially host your Avro schemas so that when the applications need to read or write data that's been encoded with Avro, well, then they could just pull that schema from there. We also have the Avro record set writer, which will essentially be used to write data in Avro format. So like I mentioned before, NiFi uses flow files, and essentially all that a flow file is the data itself and then some additional metadata on top of that. And so when you're working with NiFi, you can view your attributes for a flow file by right-clicking on a connection and then hitting list queue. And so in doing so, you would get something along these lines, and you can see it shows the flow file details. And so typically a flow file will have a unique identifier as well as a file name. And you can tag on a bunch of other attributes like we saw with the update attribute processor. If you want to view the actual content, you would end up clicking on the view button right here. And so in this example, our content is a CSV file. So you can see it's 30 rows of data characterizing years of experience and salary. The next thing I want to talk about is the architecture. So NiFi will execute in the Java virtual machine on a host operating system. NiFi is a little different than the other applications you would be used to as a developer. So most, if not all, of your interactions with NiFi will be done through a UI. And so it will actually host a web server on the Java virtual machine, and we'll be playing with that in a bit. We have the flow controller, so this will handle all of the logic related to processors, and so it will manage threads that are actually doing the work. We have the flow file repository, so this is where it actually stores all of the data related to flow files. The content repository is what actually stores the data itself. So going back to our example here, this would be the flow file repository, and then the actual content right here would be stored in the content repository. The provenance repository essentially gives you a list of events. So whenever you, like in an enterprise setting, these graphs can get quite large. And so the provenance repository is nice in that it will tell you what's happening and when, and so it can be useful for debugging or just knowing. So like most of the things in the Hadoop ecosystem, NiFi can be run in a cluster, and so it could be distributed across multiple nodes. It uses Apache Zookeeper to manage those nodes, like Kafka. So Apache Zookeeper will be responsible for electing the cluster coordinator and handling failovers. Failovers just means like the node fails or the network fails or whatever else. I guess it's important to note that the way it works is every node in the NiFi cluster will be performing the same tasks on data. It will just be performing it on a different set of data. And so let's say you're using NiFi to interact with Active Directory data. Well, then that Active Directory data might be split up across multiple nodes and they're performing the same operations on it. A administrator can access the user interface from any node, and those changes will be made across all the nodes. So now we'll get into code. So to simplify this, I've gone ahead and created a Docker Compose file. So we're gonna start off by, I already created it here. Okay, so yeah, you would just paste this. And essentially we have a image for Zookeeper. Confluence Incorporated is a company that is built around Apache Kafka. And so they've gone ahead and created a Zookeeper as well as a Kafka image. And then for our NiFi, we'll just be using the official Apache NiFi image. Right, so to start that, what we're going to want to do is I'm going to go ahead and create a additional screen here, and you're going to want to be root for this. All right, and then we're going to run Docker Compose up and then pass a D for detach, so this will make it run in the background. And it's going to go ahead and bring up our nodes here. So then when we want to access the NiFi instance, we're going to run this, and sometimes it takes a while to start up, so we'll just give that a bit here. It took a while, but as you can see now we are in the web portal. So the first thing we're going to want to do is create a processor. So you can do that by dragging the processor icon right here. And then for this example, we are going to use the generate flow file processor. And this is useful for just generating data for testing purposes. And so the first thing we're going to want to do is hit configure right here. And under scheduling, we're going to want to set this to 60 seconds because we only want to generate data every 60 seconds and not constantly. And under properties right here, so the custom text property is going to be the actual data we're generating. And if we go back to the post here, I have a CSV file. So we're going to go ahead and paste that like that, and we're going to hit apply. So going back here, the next thing we're going to want to do is we're going to want to create a update attribute processor. So again, we're going to drag this attribute, update attributes right here. Okay. And then in here, we are going to hit this little plus symbol right here, and we are going to create a schema name property, and we're going to give it a value of, I think I had test schema here. Yeah, test schema. And this will be important for later. So the next thing we're going to want to do is we're going to want to create our controller services. And so the controller services are going to be available to all the processors in our process group. And I know I didn't create a process group, but this is kind of like the default process group. Anyways, so you hit configure right here, and then under the controller services tab, we're going to hit the plus, and then we're going to need the Avro schema registry. So we're going to go ahead and take that. And then you're going to want to configure this. So you click the little gear icon right here. Under the properties tab, we're going to go ahead and create a schema. And this is where the schema name comes into play. So we're going to call this test schema. And the value is going to be our actual Avro schema. And so we're going to go ahead and take this and then paste that here. So going back here, our Avro schema essentially has two fields. It has years of experience and it has the salary. So we'll go ahead and hit OK, apply. The next thing we're going to need is the CSV reader. So we'll go ahead and add that, and then we'll configure it. So the schema access strategy, we're going to go ahead and change that. Come on. Get out of here. What the heck? All right, and we're going to go ahead and change that to use the schema name property. And so it's going to look for the schema name property on the flow file to determine which schema it should pull from the schema registry. And so we'll leave that as it is, the schema name. This essentially is a way of dynamically accessing the flow file attribute. And the next thing we're going to want to do is select the schema registry. So we'll pick the Avro schema registry. The last thing I want to do is, if you look right here, the treat first line as header attribute, we're going to want to set this to true because we had our first row as the salary and years of experience. So we're going to go ahead and hit OK. I guess it's worth noting that everything in bold here is mandatory, whereas everything else is optional. So just keep that in mind. And then the last controller service we're going to need is the Avro record set writer, and this is going to be used to write data using Avro encoding. So again, we're going to configure this guy, and for the schema access strategy, we're going to go ahead and select use schema name property. And then for the schema registry, we're going to go ahead and select the Avro schema registry. Now for the schema write strategy, you have different options. I'm just going to keep it as embed arrow schema, but you might want to change that in production. So we're going to go ahead and click apply. So the next thing we need to do is enable all of this stuff. So you can see right here the state is disabled, invalid, invalid. So you can enable something by clicking on the little lightning bolt right here. We're going to hit enable. And once our arrow schema registry is enabled, now we can go ahead and enable the rest because they depended on it. Okay, so now we'll exit out of here. And then the last processor we're going to create is going to be the publish Kafka record. So we'll go ahead and select that guy. And then again for configuring. So because this is going to be the last processor in our graph, we're going to want to terminate the connections here. So go ahead and check the failure and success. Otherwise, it'll complain and say it's invalid. And then under properties right here, so there's a few important ones. So for the topic, we're going to call it test. For the record reader, we're going to go ahead and select our CSV reader that we created in the previous step. For our record writer, we're going to go ahead and select the arrow record set writer that we created in the previous step. And then for the Kafka broker, we're going to want to go back to our terminal here. And then if I run a Docker network ls, you can see that our Docker Compose created a network called NiFi default. So we're going to want to inspect that. And then our Kafka node is called NiFi underscore Kafka1. So we're going to want to take that and replace that with here. And then for the port, and this is really important because this tripped me up, if we cat our Docker Compose file here, I don't know if you can see it. Yeah, right here. We're going to want to use 29,092 instead of 9,092. So going back here, we're going to add a 2, hit OK. All right, so before we go any further, we're going to want to create the Kafka topic. And so if we go down here, the way we can do that is by running this command right here. Go ahead and paste that and run it. So you should get something like created topic test. And then if we want to verify that it worked correctly, we can run the following command. And you can see here that we have a topic called test. It has 0 partitions, 1 replica, and a bunch of other attributes. So now I guess we'll go ahead and create our connection. So all you need to do is, if you hover over this processor right here, you should see a little arrow thing. So you can drag that to the next processor, hit add. Same thing for this, hit add. Okay, so now what we're going to want to do is we're going to want to right click and hit start. And I'm going to go ahead and stop this. And then you can see here that we have the data in the queue right here. And it's queued because this processor is stopped. And if I hit on the list queue right here, and then you click on this little eye in the corner, we have our flow file. And so you can see it has the following attributes. It has a file name, path, and a unique identifier. And then if we hit view, you can see we have our original data. And if you hit right here, this will show you your provenance. And as you can see, this is kind of like the events that occurred. So now we'll go ahead and start the update attribute, and you can hit, you can manually refresh it just so it goes faster. So you can see now that if I do list Q, and then attributes, it added our schema name called test schema. And our next processor is actually going to look for this value to pull the Avro schema from the registry. So let's go ahead and start the next one and hit refresh. And as you can see, it consumed the data. So now if we want to verify it worked, we can go back to our terminal and run the following command. And this will essentially create a Kafka consumer that will consume the data. It might take a while. There you go. All right, so as you can see, we have our Avro data right here, and every record seems to have the schema stored with it, and so we could have modified that in the configuration, but as you can see right here, this weird looking data right here is our actual data encoded with Avro. So thank you for watching. If you have any questions, let me know in the comments, and be sure to subscribe.